So, good morning students. Today I am continuing with one of the important concepts, that is maxima and minima. So, today I will tell some questions related with this. So, this is your question number 20 from exercise 6.5, and the question number 20 is, show that the right circular cylinder of given surface and maximum volume is such that its height is equal to the diameter of the base. So, how can we will solve such type of the problem? Basically, this is related with the cylinder. Given surface and maximum volume, it means in this question we have to show the volume is maximum, and at last we have to show height is equal to the diameter of the base. So how can we will solve such type of the problem? So first we will go through with the diagram. This is the diagram of cylinder. So we can say this is the height of cylinder and this is your radius of cylinder. So first we will mention, let R and H be the radius and height of right circular cylinder. Okay. After this, it is given in the question, given surface and maximum volume. So let S be the surface area of cylinder. So what is the formula of surface area of right circular cylinder? It can be given by S equals to 2 pi RH plus 2 pi R square, and we will indicate it as equation number first. 2 pi RH means curved surface area, and pi R square from bottom part and pi R square from the top part. After this, we will continue with the volume. Let V be the volume of cylinder. It means V equals to pi R square H. This is the formula of volume of cylinder. Now, with the help of these two equations, we have to show volume is maximum. So, how can we carry forward it? From equation first and second, what we will do after this, we will calculate the value of H from equation number first. So if we calculate the value of H from here, then what it becomes? It can be written as S minus 2 pi R square upon 2 pi R. This value of H we will put in equation number second. So after this step, we can say V equals to pi R square, and the value of H is S minus 2 pi R square upon 2 pi R. So R and R cancel, pi and pi cancel. It means V equals to R S minus 2 pi R square, and this is R by 2. What is the next step? It is better we will multiply R by 2 with the bracket, so it becomes RS upon 2 minus 2 and 2 cancel, and becomes pi R cube. Okay. Now we will continue with the differentiation. We will apply the concept of maxima and minima, or you can say we will go with the procedure of maxima and minima. So what it becomes? It can be written as S upon 2 minus 3 pi R square. This time we are differentiating V with respect to R. After this, at stationary point, we can say dV upon dr, or we can say it is related with also maxima and minima. After this step, what we will do? After this step, we will put the dV upon dr is equal to 0. And here we are differentiating with respect to R. It means we will calculate the value of R. So at a stationary point, dV upon dr is equals to 0. So we will put the value from here. So when we will put the value, it can be written as s upon 2 minus 3 pi r square equals to 0, and when we will solve it we will get s equals to 6 pi r square, or we can say the value of r is s upon 6 pi in under root. So this is the value of r. Now after this we have to show the maximum value. So what we will do, we will continue with the double differentiation. So when we will do the double differentiation, s upon 2 is constant quantity, so that it becomes 0, and here we will get minus 6 pi r. It means the value of double differentiation at r equals to under root s upon 6 pi. What we will get? We will get negative value. It means it is related with maxima as per the step of maxima and minima. So we can say, so V is maximum at r equals to under root s upon 6 pi. After this, what we will do? So as per the given question, we have to show the volume is maximum. Now we will come to the next part. The height is equal to the diameter of the base. So what we will do? So as you notice here, the value of s is 6 pi r square. So again we will come to on equation number first. From equation first, or you can say in equation number first, if you put the value of s, then what it becomes? You will get this type of relation or equation. Now we will solve it. So when we will solve it, we will get 4 pi r square equals to 2 pi rh. Pi and pi cancel, r and r cancel, this 2 cancel with 4, or we will get h equals to 2r. So therefore we can say, if the surface and maximum volume both are given, or if the surface is given for the right circular cylinder, then we will easily show the maximum volume, and we will also show easily height is equal to the diameter of the base. So after this h equals to 2r, we have to write, yes, we can say for given surface volume is maximum and height is equal to the diameter of the base. We have to write this thing after this. Now the second question related with the exercise 6.5, and it is the question number 22. The question is, a wire of length 28 meter is to be cut into two pieces. One of the pieces is to be made into a square and the other into a circle. What should be the length of the two pieces so that the combined area of the square and the circle is minimum? So this is the question related with the minimum, and the previous question it was related with the maximum. Okay, so how can we solve such type of the problem? So if we are saying that example, this is the length of the wire 28 meter. If we cut into two pieces, one length from this to this and second one from this to this. So if this is x meter, then what we will say about this? We can say definitely this is equals to 28 minus x meter. M for meter. Right. So how can we will write x or 28 minus x here? Let the length of pieces, first piece made into, first is your square. So let the length of first piece, it is better you write here, let the length of first piece made into square, this is equals to x meter, right? And the length of second piece made into, this time second piece is related with circle. So this is your 28 minus x meter. Right. First piece is related with square and the second piece is related with circle. So what we will say for perimeter of square? So when you will fold it or mold it, this piece, its length will never change. So we can say perimeter square is x meter, right? So basically we have to calculate area or combined area of square and circle. It means we have to calculate the area of square, and for area of square we want side into side, right? Area of square is side into side. So how can we calculate side? Or if perimeter of square is x, what is perimeter of square? 4 into side. This is equals to x. So we can say side of square. This is equals to x upon 4 meter. It means area of square. This is side into side. Now we will put the value of side. So x upon 4 into x upon 4, it becomes x square upon 16 meter square. So this is for the first piece, right? Same procedure we will do with the second piece, and the second piece is related with circle. So what we will do now, circumferences, because it is related with circle, so you can say perimeter or circumferences of circle. This is equals to 28 minus x meter. Now we have to calculate combined area of square and circle. It means we have to calculate of area of circle also, and for area of circle we want radius. So circumference of circle, this is equals to 2 pi r equals to 28 minus x. So the value of r is 28 minus x upon 2 pi, and it is in meter. So this is the radius of circle. We can say it is radius of circle. After this we will calculate area of circle. What is area of circle? Pi r square. So pi as it is, and we will put the value of r. So it can be written as whole square of 28 minus x upon 2 pi whole square, and if we solve it, what we will get? 28 minus x whole square upon, it is 4 pi, right? And meter square also will write here. So this is area of square, and that is area of circle. Now what is the question? What should be the length of the two pieces so that the combined area? Now we will take the combined area of both square and circle. So after this, what we will do? After this we will take combined area. So let capital A is the combined area. So after this we will write let combined area is capital A. So according to question, we can say A equals to area of square plus area of circle. This is 28 minus x upon 4 pi, and here we write square. So this is the combined area, right? So after this, what we will do? Now we will differentiate it with respect to x. So when we will differentiate, what we will get? We will get 2x upon 16 plus 28 minus x upon 4 pi, and 28 minus x, this is equal to 0 minus 1. Now we will solve it. So after this, we can see dA upon dx can be written as dA upon dx. This is equals to x upon a minus 2 and 4 will cancel, and we will get 28 minus x upon 2 pi. Okay, so calculation part is very important. Once you will do it, please check it again. Okay, after this, at stationary point or for maximum minima, we can say this differentiation is equals to 0. It means x upon 8 minus 28 minus x upon 2 pi, and this is equals to 0. So now we will solve it, and here we are differentiating with respect to x, so it means we have to calculate the value of x. So we can say after this x upon 8 equals to 28 minus x upon 2 pi. So how can we solve it? By cross multiplication. Now we will multiply it. 6, remaining 6, 8 to the 16, 16 and 6, 22 minus 8x. Again we will check it. Right. After this, by transfer method we can say 2 pi x plus 8x equals to 224. So if we get common 2x, what we will get? Pi plus 4 equals to 224. So the value of x is 112 upon pi plus 4. Right. So as per the question, we have to calculate the length of the two pieces. So this is the length of first piece. Okay. After this, we have to show the minimum also. Combined area should be minimum. So after this, what we will do? This is the first differentiation. So after this, we will continue with double differentiation. So when we will solve d square a upon dx square from here, right? This is the first order derivative. If we continue with this, what we will get? We will get 1 upon a minus, we will do the differentiation of this. So 1 upon 2 pi we will write as it is, and this is 0 minus 1. So when we will solve it, what we will get? We will get 1 upon 8 plus 1 upon 2 pi, and this is your positive, or you can say greater than 0. So we can say this is the concept of right. So after this, we can say, so A is combined area, so A is minimum at x equals to 112 upon pi plus 4 meter. Right. After this, we have to calculate the length of the second piece, because the length of the first piece we already calculated here. After this, now length of second piece, in starting the length of first piece it was x meter, and the length of the second piece is 28 minus x. So what we will do, we will put the value of x. So here we will put the value of x from here, and now we will solve it. So pi plus 4 is the LCM, and when we will solve it, we will get 28 pi minus, we will multiply this 2 remaining 3. So 112 minus 112. Okay. So we will check it once again. Here we get positive sign. Yeah, this is correct. So 112 cancel 112. So we will get 28 pi upon pi plus 4 meter. Once again we will check it. We will multiply 28 pi, 2 remaining 3. 112 is right. Okay, it will cancel and we will get. It means in this question we can say combined area of the square and circle is minimum at x equals to 112 upon pi plus 4 meter, and the length of the first piece is this, or you can say this is equals to length of the first piece, and this is related with the length of the second piece. So definitely these questions are little bit lengthy, but the formulas and the concept of maxima and minima or the steps are clear, then we will solve these type of questions very easily. Now I am continuing with the question related with CBSE 2009. And the question is find the volume of the largest cylinder that can be inscribed in a sphere of radius r centimeter. So how can we will solve such type of the question? First we will make a diagram. This is the sphere, and now we will continue with here we will make one cylinder as per the language of the question. So we can say from this point to this point, this is capital R, radius of sphere, and we will denote here O. This is A, B, and this is your, you can say one more line is there, C point, right? So if I am saying this is H from here to here, and this is also H, so it means we can say height of the cylinder capital H is equals to H plus H, it becomes 2H, and this is the radius of that cylinder. So we will write here is let small r and capital H be the radius and height of the cylinder, right? And capital R is the radius of sphere. So how can we show the volume is maximum, largest means maximum. So we will write volume of cylinder, this is equals to pi r square h, right? So v equals to pi, and how can we calculate the value of r square? So in this triangle O, if you mark here one more point D, in triangle ODB, this angle D is equals to 90 degrees, so that we will apply Pythagoras property here. So what is the value of r square? From here we can say in triangle ODB, capital R square equals to h square plus r square. So the value of r square equals to small r square equals to capital R square minus h square. So we will put the value here, and it can be written as r square minus h square, and the value of h is related with 2h, as I said earlier. Okay, so v equals to 2 pi r square h minus h2. Okay, now we will differentiate with respect to h. So what we will get? 2 pi r square minus 3 h square, right? Now we will go with the steps of maxima and minima. So at stationary point, we can say dv upon dh equals to 0. So when we will put the value, it can be written as 2 pi r square minus 3h square equals to 0. So r square is equals to 3h square, and the value of h is r upon under root 3. We will check it again. When we will solve it, we will get r square equals to 3h square. So the value of h is r upon under root 3. Yes, it is right. After this, we will continue with the double differentiation as per the steps of maxima and minima. So when we will go with double differentiation from here, what we will get? We will get 2 pi, as it is differentiation of r square is 0 minus 6h. It means we will get negative value here. That's why we can say it is maxima or largest. So V is maximum at h equals to r upon under root. This is the one part of this question. Now after this, what we have to show? We have to show volume of the largest cylinder. Okay. So this is the largest concept of volume. After this, we have to find the value of that volume. So how can we calculate the value? We will put the value of H here. This is equation number 1. If it is, we mark this equation as equation number 1, then how can we will calculate the value of volume? So from equation 1, we can say V equals to pi. Now we will put the value of H. So it becomes R square minus R square upon 3 into 2R upon under root. After this we will solve it. So when we will solve it, what we will get? So after this we can say V equals to pi 3R square minus R square, so it becomes 2R square upon 3 multiplied by 2R upon under root 3. It means we can say V equals to 4 pi R cube upon 3 under root 3. It means we can say for such type of the problem, volume of cylinder is maximum or largest, and it becomes or it is equals to 4 pi R cube upon 3 under root 3, where R is radius of sphere and small r is radius of cylinder. So with the help of this procedure, we will solve this problem very easily. So with the help of these questions, you solve the question which is related with the maxima and minima. This concept is very important. So whenever you do the calculation part under maxima and minima, be careful, put all the values very properly and follow the steps of maxima and minima. So with the help of these questions, I hope you will solve the questions which are related with the concept of maxima and minima. Thank you very much.